Welcome back, guys. Mark here, and I was so excited to keep going with the tutorial. I'm going to give you 2 videos in one night. So in the previous video, or the tutorial in lesson 9, we went and we put a transparent background on our text we were drawing onto the screen so we could see our background through that text. So what I wanted to do is I wanted to teach you guys about collision detection. That way we can start doing some fun things with our game. We can start removing them, adding them. We can start racking up some stuff. So the first thing I want to do is go ahead and build in our subroutine for our collision detection. So right above gameworld.quit or gamingworld.quit, let's go ahead and add a new branch label called collision.detection. And then because it's a subroutine, we're going to return. Because we're going to call it, it's going to execute its code, and then we're going to go right back to where it was called from and execute any code underneath it. So the first thing we want to go ahead and do is actually get the location of our sprite. So we'll use the handle of our window, and we're going to say sprite XY exclamation mark. And we're looking for where our Pac-Man is, so PM, so Pac-Man. And we're going to assign the Pac-Man's X to X, the Pac-Man's Y to Y. We then want to see if he collides with anything. So the handle of our window once again. You guys are probably seeing a theme here with that. We're going to say sprite collides. And we're saying, okay, what sprite collides? So we want to look for if our Pac-Man sprite collides with anything. And we're going to assign anything he collides with to a list. So if he collided with a green block, that would be on our list. If he collided with a red block, that would be in our list. Anything he's colliding with is in this list with a space in between each one. That allows us to use a special function or a function built into Liberty Basic. So we'll use a local variable of findBlock. If you remember, local variables are only visible to this branch label. They're not visible to our entire program. And we're looking for this instruction. We're actually passing in our list. And what we're looking for in our list is green block, GB. And if GB is in this list, findBlock will be assigned 1. The number 1. If the green block is not in this list, findBlock will be 0. That allows us to build a nice if statement. And let's put a space in between these just to give them some nice formatting. You guys are probably learning I like to format a little bit. And so now what we can say, if findBlock is greater, not L, but greater than 0, then we're going to say our Pac-Man X is equal to our X variable from finding the sprite location minus 2. And I'll show you why there's a minus 2 there. And don't forget to add the end if. So now we're actually going to find our green block. And if we crash into our green block, we're going to set our Pac-Man back 2 pixels. And right now, if we were to do this, we wouldn't get anything because we don't have our subroutine called for our collision detection. So I'm actually going to copy our branch label. And right above where we're setting the X and Y position of our Pac-Man, we want to go sub and paste in our call to our subroutine. And we'll do the same to the left, go sub. And make sure it is above where we're setting this X and Y, because if it's not above this, it'll actually walk right through our sprite. Even though it's detecting the collision, it'll still set this X and Y on us. So now, let me switch my scene back here. If I run this, you guys can see as I go across the screen, I'm going to crash into our green block, and you're going to see it's pushed back. It won't let us through. And we can go back the other way. Now, if we didn't have that -2 pixels, and you'll see there's a huge gap right here, you guys can see on my cursor. and that is because of the sprite scale, and we're not going to worry about that. So we're going to not scale him now. Let's get rid of our scaling. Let's use his actual size. Now you guys can see him. Going to go across, and he collides with it. It looks a lot better now. You can see he bounces back. You know, he's touching the square, but he's going back 2 pixels, and we can go back the other way. So we can't go any farther. If we didn't have the -2 when we're setting the PMX to that X position, so let's get rid of the -2. I just want to show you guys the side effect. So we're going to go across, we're going to hit this block. See, he hit the block, he ran into it, he collided with it, but we can never get away from it now. And the reason for that is because right now we're always on the green block. So we're always colliding with it, so it never allows us to actually move back and transition the other way. So we're always at basically 470. Once we get to 468, we can actually move away from the block because collide with green block is no longer true. So I just wanted to show you guys that why we have to do that offset. It just helps avoid that issue right there. So I'll put it back in. We'll run it. You guys will see we hit this block. He's going to bounce a little bit, but we can still go back the other way now. He can still chomp. So pretty cool. Nice collision detection. So the next part of this lesson, I actually wanted to remove a sprite. So I was thinking about the best way to do this, and I thought, well, we could remove the green block, which would be cool. But then I thought, let's add another sprite. Let me go ahead and open graphic scale. I kind of showed you guys this program before. We'll do a 32 by 32. Make it large. This will be real quick too. So we'll go ahead and zoom in about 1500%. Grab this. Let's grab, let's say, our nice big red dot. We'll go in 4x4. And we'll make sure we're over 4x4 here. Nice big red dot. We'll go ahead and we'll save that. We'll do a save as. And let's go ahead and find, we don't want it in our images folder, so we'll drill down to where we're working, which is lesson 10. Lesson 10, collision detection images. We want to save it as a bitmap. And let's just call it dot. So now I close that. Go back to lesson 10. We'll look in here. Here's our dot. But you guys remember what we need to do. We actually need to turn this into a sprite. So I'm actually going to go back in. I saved that sprite mask maker. Don't mind my mess here. I do a lot of development things. It's terrible. I know, but I'm going to use our sprite mask maker. This thing comes in handy. I told you guys about this in a previous episode when we first started talking about sprites. This is your friend. Open it up. It's going to ask me where I want to save it. In images. And basically we'll call it, say, dot red or red dot. How's that? Red dot. Save. We're going to exit that. We don't need that anymore. And now let's go back and look into our lesson 10 collision detection. We now have our red dot. Perfect. That's what we want. Nice happy red dot that we can use. Let's go back here. And we're actually going to bring this into our program. So we need to load the bitmap. So load BMP. And this might be a repeat, but at least it kind of drives it home. So we'll call it RD red dot. And it's in our images folder. And he's red dot BMP. So now we've added our red dot. We're loading it. So let's go ahead and bring it into our game. So gaming world, add sprite. Once again, this will be RD, red dot, just make it easy. Then gaming world, gotta spell it right. We're gonna say sprite, XY, RD, we'll say, how about 250 by 540, how's that? We can run that. Let's look where it is on the screen. There's our red dot. And I actually want to look at our sprite because we got, I see what we got going on. So I'm actually going to edit this by hand. So let me do this. I'm going to open it with Paint just to make this as quick as possible. I'm going to zoom in, go back here, use our bucket fill this in with black. There we go. Is that what I wanted to do? Probably not. Let's see what happens. Let's see what happens. It's probably going to be a terrible disaster. I know what I did wrong from the get-go, but let's see. Yeah, yuck. Yeah, cancel that. So let's go back. Let's edit this dot. Like I said, I'm not going to edit any of this stuff out. I want to have you guys see the problems you go through when developing, the challenges you're going to run into. So what I was supposed to do is fill that in black to begin with. Save that and close this now. We need to go back and open up our Sprite Mask Maker, which we got to drill down through my terrible development folders. Sprite Mask Maker, we'll run it. Run. Go to lesson 10. Like I said, someday I'm going to rebuild that. Open up our dot now. It's going to want us to save it. Lesson 10. We're going to save it right over red.bmp. It's not going to save over it, which sucks. So we'll go here. We'll go back. We'll delete red.bmp. Yes. And now we'll save it. Now we've got our perfect sprite mask. So we can close this, get rid of that. Look in here. Now let's just go ahead and run our solution. There we go. It looks a lot better. So you can see we're just going to pass through them. And we're really not going to be able to do much with them. And I think we're going to move them down a little bit lower, that red dot. Or move it down a little bit lower. So let's try 545. Oop, not 44, 45. Let's see how that looks. Lines up pretty good. I'm going to say we want to go 550. Just trying to get him about level with Pac-Man. There we go. That looks pretty good. Yeah, I like that. Like it a lot. So we got our red dot on the screen. Now we want him to eat that red dot. So when he's coming along, if you guys remember Pac-Man, you know, he'd run across the screen and eat things. So let's go ahead back into our collision detection. And we're going to make another local variable under here. And we're going to call it find dot equals. And then we're going to use our instruction again. Instruction. We're going to pass in our list. Forget the comma. And our red dot was RD. So let's look for red dot. And then we're going to say if find dot is greater than 0, then, now here's the new command you guys haven't seen yet. So gaming world, this is going to be remove sprite, and then we're going to say RD, red dot. Don't forget the end if. So now if we crash into our red dot, we're going to remove it. So if I go ahead and I run this, I'm going to come across, red dot's gone, and we still collide with this. So that's how you actually remove sprites. So kind of a shorter lesson, but I hope you guys got a lot out of it. It's sprite collision, sprite detection. Hopefully you like the new commands. You like that you can actually bump into things now and actually set yourself back. One of the things I would say when removing sprites is once you remove it, it's going to be gone from your list. So if you're going to have to add it again and go through, and we'll do some of those challenges. We'll talk about it later on, because once you remove it, you have to re-add it. So if you were trying to remove it again right now or work with it, you would actually get an error. The other thing we want to make sure we do is we want to unload. So unload our BMP, unload BMP, and that's our RD. So we want to unload that bitmap later on and free up that memory. So don't forget to do that. But hopefully that gives you some ideas. You can work with your dots, or you can work with your sprites, like the dot, remove it from the screen. One thing we could do is we could actually make a score, a global score counter, and kind of use the same command we use for our text. And actually, every time we ate a dot, we could add 10 to the score up in the right-hand side of the screen. So we could actually add up our points. But hopefully that gives you guys quite a few ideas for sprite collision, sprite detection, and how to remove them and how to look for any collision detection at all. But I hope you guys liked the video. If you did, please hit the thumbs up button, and if you haven't already, please don't forget to subscribe. See you in the next lesson, guys.